The bending in the nodes is something that only happens very occasionally. There's a misunderstanding about it. A lot of people think you will find it in every single crop circle. I only found it in a very few crop circles. A lot of times people will mistake, I will give you an example in the standing crop. This is the way how crop grows. It comes out and then goes up. Now when this goes down, it gives you the impression that there's a bend here. That's not the bent nodes. The bent nodes are the ones, in fact, that are the middle ones, the straight ones, that are bent. And that is amazing. That's unexplainable. I believe there's a phenomenon. I'm not going to look for bent nodes anymore in every single crop circle. I try much more to get the feel from what does it do to me, what does the shape do to me, but it's the general feeling. And all the plant research, I will leave it up to others, to Nancy Tolbert and people like those. They can do this kind of research. That's not my business, in fact.
I heard about this guy, this Michigan guy, this Levengood, who had started to do plant work. I was staggered that there was somebody in the United States interested. I mean, delighted and really amazed to find that there was anybody, because by then I already had learned that there were crop circles all over the country. They weren't just in England. And they were in the United States, they were in Canada, they were in other Western European countries. We knew about them in Australia by then. And both Burke and Levengood, as far as I know to this day, are pretty much committed to the idea that the causative agency is an ionospheric plasma, and the plasma that's generated in the ionosphere, and then descends to the Earth's surface, goes to certain locations for whatever reason, the aquifer connection, some sort of magnetic anomaly or whatever, and leaves these impressions in the crop as a result. The design aspect is the thing that causes the most trouble for people with that explanation. In fluid dynamics and in numerous other areas of science, you see fabulous designs exhibited all the time. I mean, you just look for a minute, think of the head of a sunflower seed, just think of what it looks like.
Or snowflake is a common.
I mean, how amazingly intricate is that? I mean, the shell of a seashell, snowflakes. I mean, there are millions and millions of examples of nature creating incredibly intricate designs. I mean, the major point is, I think, for people who don't know anything about crop circles, is not to jump to the conclusion that because you've never seen anything like this before,
right,
that it is supernatural.
right.
It might be supernatural, I don't know for sure, but look first at the obvious. We have still only scratched the surface of what is there to be understood. And it may be that many things which have historically been thought of as supernatural are, in fact, part of the natural world, but occur only randomly or only occasionally or under certain circumstances, and that they're actually just part of the natural environment that nobody's bothered to study very much and doesn't understand yet. The thing with science, the beauty of it is, if you get a piece of information that doesn't fit, you have to go back to square one and you build another theory. You follow the data. You don't come up with an idea and then make things fit. You see what's actually there. And what Levengood documented beautifully, and I would guess tediously for many, many years, were the basic changes in the plants. And he also discovered magnetic particles in the soils that are very unusual. One of the things that he discovered was that the seeds taken from crop circle plants grew totally differently than the controls. What this is a bunch of seeds taken from a formation and a bunch of seeds from the controls in a lab tray. And he's germinating them. He has a germination chamber. It's calibrated to a certain temperature, a certain amount of moisture, et cetera, et cetera. And it's done in a very standard way. If the crop was young and immature, the seed was not fully formed when the crop circle occurred, the seedling was depressed, the seedling's energies. Often they wouldn't germinate, and if they did germinate, not strongly enough to be viable. However, in mature crop, where the seed was already formed when the energies hit, then you got exactly the opposite. You got increased growth and yield. Normally a germination is 4 days. All they're looking for is, does the seed germinate or not? That's the beginning of what Levengood does. Once that is done, he's then measuring the root and shoot development for up to 14 days in some cases. He's wanting to see what happens subsequent to germination. This is this case in Maryland where the elongated nodes occurred. There were these swaths cut through the crop, and the nodes are bent to the left and the right. Node bending is a natural response of the plant. If it's young and growing, if it's knocked down and not killed, it will try to reorient itself according to gravity. It's called gravitropism, or phototropism. It's just it reorients itself to the light. So if you go to a crop circle and nodes are bent, if you don't know when that crop circle occurred, and you don't know the age of the crop at the time, you don't know whether this node bending might be due to natural phototropism or whether it's something that occurred during the event. If you get there quickly and you know that it has just happened and you find massive node bending like this, these 90-degree angles, this was part of the phenomenon. It actually bent the nodes. I want to show you the node enlargement photo. The top is our nodes. These are stem nodes taken from inside the formation. The bottom shows you the controls, which are taken at a considerable distance outside.
What are the characteristics of this node lengthening?
What Levengood says is going on is that the moisture, remember the plant stem is hollow, and the nutrients, the moisture which nourishes the plant, goes up through this stem. Plasmas, a fact about plasmas is that they emit microwaves in bursts, pulses. His idea is that the microwaves from these pulses are connecting with the moisture inside the plant stem, just like they would in your microwave oven, heating the plant up, which softens it and allows it to fall. The moisture inside turns to steam, and as it does so, it has to escape. Well, if the plants are young and pliable, the outer fibers are pliable, the steam escapes by stretching the nodes. That's how you get the elongated nodes. If the energy is extremely intense, and or if the crop is old and the fibers are tough, then it can't get out by stretching it because the fibers won't stretch, or it's just too much energy. Then it blows a hole right out at the node.
Okay. That's called the blown node.
Yeah, and those are our exploded nodes. These are samples of corn. We have done a number of corn formations. These are crop circles that occur in the corn. But you see, what we're looking at here is these. You want to see the light coming right through those. The crop was down, and here were these expulsion cavities. The amount of energy that it would take to do this in full-grown corn must be quite astounding. When we do this sampling, a lot of people think that we take a plant stalk here or there. Well, we don't. We take hundreds of plants, thousands often, say 50, 60, 70 samples, and each sample it consists of between 10 and 20 plants. And then we do the same thing in the controls, starting immediately outside the circle and going up to 500, 1,000 feet away in several directions. Then the idea is that you compare what you see in the plants inside to what you see in the plants outside.
How do you explain this? Look at the bend on that guy.
It seems like maybe 1 out of 100 have these bends that, if it were mechanical, they'd all be broken.
Here is this very nice looking, what I call a plumber's bend. It's absolutely 90 degrees going down. Master Lou found that one.
Beauty, that one. Huh?
Yeah.
Yeah, that one's good. Wow, you find a magical bend.
Yeah, quite a lot of them.
Yeah. Ah, lovely. That's a